In this next step of the practical work, we're going to look at use of chemical drying agents. Even though you think you separated all the water from your material, there are still likely on a molecular level to be traces of water around. These can be removed by chemical drying agents. Chemical drying agents are typically calcium or magnesium, chloride or sulfate, but all are anhydrous. In other words, they have no water of crystallization. Here we're using magnesium sulfate. Magnesium sulfate can put around itself 7 molecules of water of crystallization, so it's good at removing water. What we need to do is add several spatulas of magnesium sulfate to the sample that we're trying to dry and swirl. We're looking for a snow globe effect. The initial magnesium sulfate will clump when wet. We need to add sufficient magnesium sulfate that the surplus will not clump. You may notice on the conical flask the chemist performing this experiment has used a piece of shorthand that you may not have seen. She's written ETOH, which stands for ethanol. ET is a shorthand for CH3CH2, just like ME would be methyl. The next step is to fold a piece of fluted filter paper. Folded fluted filter paper has more active surface area to allow filtration than the standard fold a piece of paper in half then in half again. An alternative using fluted filter paper would be to use Buckner filtration. Prior to pouring the mixture through the filter paper, you will notice that the chemist has agitated the mixture to try and get as much solid into the filter paper in one go as possible. Obviously, we would have to wash through any remaining solid from the conical flask using ice cold ethanol, the solvent in this case, to maximize our product yield.